Hello, and welcome to 5-Minute Math. Today we are looking at the 6th grade concept of equations for area. This is standard 6.8C in the great state of Texas, and we are using item number 26 off the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So we have a table, looks like an input-output table, but actually it is the relationship between the perimeter and area of 4 different squares. And we need to find an equation that relates the area of a square to the perimeter of a square. But I think it's going to help if we draw some visual pictures here. So let's take a look at this very first square right here. Obviously, since we're squares, we know that they all have the same lengths. So we have an area of 1, so there's one little square on the inside. We have a perimeter of 4, and that makes sense because there's just an area of 1 on the inside. So the perimeter is going to be 4 times the area in that case. So now we have an area of 4, so I'm going to draw this. I'm going to draw some dashed lines here because these are going to be our imaginary squares inside the square. And so we've got an area of 1, 2, 3, 4. And now we've got 1, 2, 3, 4, 5, 6, 7, 8. So there's my second one right there is my relationship. So it's going to be twice as big on that one. So it's not necessarily a multiplicative relationship. And then we have an area, a square unit of 9 here. And so let's just draw some dotted lines. So we got it's a 3 by 3 grid. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. And then outside 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 9 to 12. So as you notice, the area is getting bigger. The perimeter is getting closer and closer to the area until we finally finish out with, look at this. In this 16, it's actually the same. We have both an area and a perimeter of 16 because it's 4 by 4. So you've got 4 across, so there's your 16. And then you've got 4 all the way around 4 different sides. And so that is an interesting dynamic of how the perimeter gets a little bit closer to the area as we get closer. But how does that help us finding this equation? Well, now that we know that how they are related to each other, what we could do is we can actually just start plugging in some of these numbers and just use our algebraic reasoning. So A equals, let's look at this number 1. I'm just going to plug in our values. A is, we'll start with 1, and we'll just use that one. P, so that's 4 divided by 4 times P 4 divided by 4. Let's see. So 1 equals 4 divided by 4 is 1. 1 times 1. Well, that does make sense. Let's question mark this one. We might come back and do another one if we need to. A equals 1 equals, and then P4 minus 4. Nope, that's not going to work. The first one doesn't even work for that one. This one looks a little bit more complex here. H. So 1 equals, so I've got P plus 4, so that's 4 plus 4 times, let's make that multiply there, 4 plus 4. So that's 1 equals 8 plus 8, no. And then A equals P. I know why they did this because look down at the very bottom. Because A does equal P down on the 4th one, but not on the first 3, so that's not going to be it. So it looks like F is going to be our answer, but let's just double check with one more. I'm going to do one more down here, and let's do our 9 and 12. So area 9 equals, so I've got 12 divided by 4, and that's going to be times 12 divided by 4, so that's 9 equals 3 times 3, and yes, that does work. So our answer is going to be F.